Welcome students. This is the third lecture for the theory of surfaces. For better understanding, you must watch the first two lectures for the theory of surface. Today, we start with direction coefficient of a vector on a tangent plane. Let us begin with the definition of direction coefficient. Let R of uv be a surface of class G, defined in domain D. Let P be any point on the surface. Let R of alpha t, beta t, be a curve lying on the surface. Let R of alpha t0, beta t0, be a point on the surface. If R1 and R2 be the derivatives R with respect to u and v respectively, and the unit normal vector is n, where h is not equal to 0, then every vector b can be expressed as follows. This vector b is the sum of two vectors b and capital N and gamma r1 plus delta r2. Here, b and capital N is perpendicular vector to the tangent plane, and gamma r1 plus delta r2 lies on the tangent plane. B and capital N is called normal part of B. Bn is called the normal component of B, and gamma and delta are called tangential component of B. And gamma r1 plus delta r2 is called the tangential part of B. Now, if we zoom this picture, in this series of lectures, we concern only the vectors, which are tangents to the surface, that is the normal component, is 0. And the vectors will be denoted as a pair of gamma and delta. A vector b in the tangent plane at a point P is conveniently described by the components of the unit vector in direction of the vector b. These components is called the direction coefficient of the vector b. Let the vector b equals to gamma r1 plus delta r2 is in the tangent plane. Then, the direction coefficient of B is Lm, where L equals to gamma by the square root of gamma square plus delta square, and m equals to delta by square root of gamma square plus delta square. Note that L square plus m square equals to 1. In this picture, you can see the black vector b, which lies in the tangent plane. Lastly, I elaborate the angle between two directions or vectors. Let A and B be two vectors on the tangent plane. Let the angle between these two directions is theta. Then, cos theta equals to a dot b, and capital N sin theta equals to a cross b, where capital N is the unit normal to the tangent plane. Thank you for watching this lecture. You can note down this explanation. If you have any query regarding this explanation, you can write down in the comments section.